Hey everyone, welcome, I am Amjith, and today I am gonna share with you actuators. Actuation systems convert the input signals computed by the control systems into forms that can be applied to the actual process and would produce the desired variations in the process physical variables. Convert the controller output, which is essentially information without the power, and in the form of electrical voltages, or at times pneumatic pressure, in two ways. Firstly, it converts the form of the variable into the appropriate physical variable, such as torque, heat or flow. Secondly, it amplifies the energy level of the signal manifold to be able to cause changes in the process variables. In industrial control systems, an actuator is a hardware device that converts a controller command signal into a change in a physical parameter. The change in the physical parameter is usually mechanical, such as position or velocity change. The controller command signal is usually low level, and so an actuator may also include an amplifier to strengthen the signal sufficiently to drive the actuator. With the increasing utilization of automated machinery systems, there has also been a rise in the demands for actuators, which play a vital role in the automation process. Actuators, which are responsible for moving, controlling or positioning a mechanism or system, make the working of automated equipment seamless and easy. There are several areas wherein actuators play a crucial role in automated systems. Process industries control the operation of various equipment in an industry. Solar, the industry utilizes several types of actuators including ball screw and acme actuators to automate the functioning of various solar tracking devices, solar power concentration equipment, photovoltaic device, and photovoltaic concentration equipment, among several others. Military, these military actuators are basically equipped in tanks, cannon carriers, airplanes, fighter planes, helicopters, ships, and robots, because they offer complete movement. Actuators for the military industries are ruggedly built to withstand harsh environmental conditions, extreme weathers, and severe attacks. Satellite, the use of several linear and rotational actuators help automate the working of several equipment. These include dish antennas, sensors, earth imaging equipment, and so on. Specially designed and high-quality satellite actuators are sought after for precise positioning and motion control for the industry. Construction, the industry depends on high-speed automated machines, systems to carry out several dangerous and tedious tasks. Actuators of varied types are used in these systems, because they are known to delivering powerful movements to heavy-duty machineries like loading trucks, towing trucks, and cranes. Actuators for the construction industry are built to offer durable, reliable and long-lasting performance.
Control valve actuators control fluid in a pipe by varying the orifice size through which the fluid flows. Control valves contain two major components, the valve body and the valve actuator. The valve body provides the fluid connections and a movable restrictor comprised of a valve stem and plug that is in contact with the fluid that varies the flow. The valve actuator is the component that physically moves the restrictor to vary the fluid flow. Three actuator types are used in control valves, and they include spring and diaphragm, solenoid, and motor. As the name suggests, the spring and diaphragm actuator uses a spring and a diaphragm to move the valve stem and plug. A 15 psi pneumatic signal enters the housing at the top of the actuator. As pressure is exerted on the diaphragm, a downward force is applied against the spring, which moves the restrictor. The diaphragm moves until it creates an equal but opposing force against the spring, at which time the motion stops as the plug meets the valve seat. With no air pressure, the restrictor is pushed upward by the spring to act as a normally open control valve. To vary the position of the restrictor and flow through the valve, a current-to-pressure transducer can be used to provide a 3 to 15 psi signal to the diaphragm. At 3 psi, the valve is maintained open, and at 15 psi, the valve is maintained closed. Pressures between the 3 to 15 psi range proportionally change the flow of the valve. For example, a pressure of 9 psi applied to the diaphragm moves the spring and valve stem to 50% of operating range. For on-off control of the valve, a solenoid is used to actuate the valve to a fully closed or fully open position. Applying current to the coil generates a magnetic field that moves the plunger downward against the return spring. With zero current applied to the coil, the spring pulls the plunger upwards to the fully open position for a normally open-state control valve. Another method for variable valve positioning uses a motor and is referred to as proportional control mode. Using a gear motor attached to the valve stem, a servo amplifier provides a DC control signal that moves the valve to the desired position. Feedback is achieved with a wiper arm attached to the valve stem that sends a signal back to the servo amplifier where the position is monitored. The servo amplifier drives the motor until the control signal is equal to the feedback signal.